Good afternoon, everyone. I'm CA Rashmi Lonikar, and I'm going to take some topics for you in mathematics and statistics. Okay, so welcome to the new batch, and it's a beautiful day here. So let us begin our studies. And good afternoon, Jannavi, Venkat Lakshmi, and Om. Thank you for the flowers also. Yes, thank you so much, Komal Preet, Sneha, Ananya, Ruhani, Jignesh. Okay, okay, your name is Pal. Okay, Pavitra, Harshita, Rishikesh, Shaunak, Suprava. Okay, Nishi, Antima, Aditi, Sahana, and Preeti. Okay, a very good afternoon. Mangesh, Ananta, Apurva, Sunil, Mansi, Shreya, Shruti, Mohammed, Sundaran, Prutha, Kajal, Keshav. Okay, lovely. Amit, another Janvi, and Sakshi. Excellent, excellent. Okay. So all of us are ready to dive into the topic of permutation and combination, right? So this is a very important topic because once you are able to master this topic of permutation and combination, when we go for probability, it becomes very easy to solve. And also because probability has a lot of practical application, so the study of permutations and combinations is also very important over there. Some of you may, after your graduation, you may want to go into analytics, business analytics, or etc. And then you're interested in the topic of combinatorics. So in all those cases also, this is your foundation. Okay, for in CA foundation, this is your foundation chapter, permutation and combinations for bigger things to come. Okay, so having said that, let us dive into this. Let me take an example first, and then we could understand this better. Okay, suppose I have 5 objects. Okay, A, B, C, D, and E. Okay, so how many are there? 1, 2, 3, 4, 5. 5 objects. Out of that, I'm taking 2 at a time. Okay, so out of these 5, I want to make subsets of 2 each. Okay, so how many are there? So 5 objects are there, and then I want to take 2 objects at a time. Okay, I want to do that. So all of you are with me. So I can have AB, I can have BA. If I start with A, then I can have AC and I can have CA. Then I can have AD and I can have DA. Okay, sorry for that. Okay, where is it? Yeah. Okay. Then I can have AE and EA. Okay. Then after this, what do I have? I can start with B. Then if I have B, I can have B I already have. So I can start with BC, CB, BD, DB, BE, BE and EB. Okay. Then I go to C. Then CA I have already taken. Then CB also I've already taken. So this is CD, DC, CE, EC. Now, if I go for D, I have already this. So I have DE and ED. So can we count how many are there? So can you put it in the chat box? How many options do I have here? Can I count? 1, 2, 3, 4, 5, 6, 7, 8. So what I'm missing? Is there anything missing? That also we'll see. So can you put it in the chat? Okay, this. Give me a second. I would like to just close this notification. Yes. So how many do we have? Yes, Asha, good afternoon. Yes. So there are 20. Some are saying 10. Why? Okay. So there are total of 20. Okay. So we have 20. So AB, BA, AC, CA, AD, DA, AE, EA. Then BC, CB, BD, DB, BE, EB, CD, DC, and CE, EC, and DE, ED. So we have these 20. Now when I have this, so when I say AB and I say BA, so what happens is the order when it is important, when the order is important, okay. For example, who has come first in the class? If I say AB or BA, that is not the case. If A has come, he will get annoyed. Why? Because he has come first. Why are you saying B has come first? So when order is important, you say this is permutation. Okay. When the order is important, you say it is permutation. Okay. And what happens is, when I say, it will not matter BA or AB. Suppose I want to choose two friends with whom I'm going for the movie. Okay. So I'm choosing AB or BA. Will it matter? No. Whosever name I take first, it will not matter. So in that case, what happens is, when in this case, AB or BA are not taken as separately, they're treated as one. So I cut this. AC and CA are the same. So this ADDA 1 and EA this similarly. And so we are left with 10 options. So we are left with 10 options. And so this is called as combinations. Okay. Okay, when there is a selection and the order is not important, it is called as combination. Clear? So this is for your basic understanding what is the difference between permutation and combination. Then a very important thing is what is called as factorial. Okay, what is called as factorial in mathematics and statistics. So what is factorial? So when I say n factorial, it means I start from the number 1 and go up to n, multiplying the numbers. So 1 into 2 into 3 into 4, so on, n minus 2 into n minus 1 into n. Okay. So this is very important. Okay, this is very important that you should know of. So when I'm saying 3 factorial, let us see 3 factorial. What should I do? I should write from 1 to 3. So 1 into 2 into 3. So 1 into 2 is 2. 2 into 3 is 6. Okay. So similarly, you can practice for this. 4 factorial is 24. 5 factorial is 120. 6 factorial is 720 and 7 factorial is 5040. Now, what I would like to suggest is that you should, as far as possible, you should know these. Okay. But after that, what happens if I've got 13 factorial? Okay. Then you can have this 5 factorial as your baseline. Okay. Or 7 factorial. Okay. You should know at least these two. And from there you can do it. But then I'm also going to talk to you about a golden rule in factorial, which will help you solve this very easily. Because every time doing on the simple calculator that we are allowed in the exam, we are not allowed the scientific one where I just put in the number and I just press the factorial symbol and then I get the factorial. No, here what do I have to do? 1 into 2. Every time I have to click on the equal to sign or multiplication sign, only then I get the number. So for that we are going to study the golden rule of factorial. Okay, so once we start doing that, I'm going to tell you about it. As we solve the problems, I will tell you about the golden rule, which is a very simple rule. If you could do this, if you could use the formula, excellent. But some of us are a little like we get confused in a lot of formula, and by the end of the whole study, you have a whole notebook full of formulae, right? And so at that time it becomes difficult to remember all the formulas. So at that time this golden rule is going to be a magic wand in your hand, so that you will never lose marks in permutation, combination, probability theory. Okay, so so there are these two rules also. Apart from the golden rule, we're going to talk about the multiplication rule, which is the simplest rule that we all know about. Suppose first thing can be done in m different ways, and when that thing is done, the second one can be done in n different ways, then the total number of ways in which both the things can be done, not done simultaneously is m into n ways. Okay, so if first thing I have two tasks in my mind, I have to do those. I take the first task and I complete it. Then I do the second task. Then combined way in which these two can be done is m into n ways. Suppose like I have to select 10 students. I have to select say 7 students, and in the to each of the 7 student I want to distribute 10 chocolates each. Okay, but out of the class, like I suppose I took a presentation, I'm trying to select 7 students out of the class, so to whom I want to distribute chocolates. So what is the first step? Selection of the student. So out of the class, I'm selecting 7 students, and then I'm distributing them 10 chocolates. So if I just tell you, okay, I have to give, so in what way I can do is 70 ways. Okay. Now, there is this other way. Okay. So if one can go to the school by 7 different buses and then can come back by 4 different buses, total number of ways of going to and coming back from school is 5 into 4 ways. Okay. So I can go by B1, I can go by B2, I can go by B3, B4, and B5. So when I go to school, I can take either of these buses. So what is the option that I have? There are 5 buses I can choose from. But while coming back, what is happening? The buses are different. Okay. So in that case, I suppose I have D1, D2, D3, and D4. So what can the combination be? B1 to D1. Okay, I can go by B1 and come back by D1. Then I can go by B1, come back by D2. And so for each option of going, I have 4 options with which I can come back from school. So with each option, each bus option that I take while going to the school, while coming back, I have 4 options for coming back. Okay, I can choose between any of the 4 buses to come back. So for each option, if there are 4, for 5 options, it will be 5 into 4, that is 20 buses. Okay. So this is the multiplication rule. Now what does the addition rule says? If one job can be done in m ways and an alternative job can be done in n ways, then either of the 2 jobs can be done in m plus n way. Okay. So taking forward the earlier example, so for example, while going, I have the option of bus and auto. Okay. So what happens here is that there are these two options. So I can go either by the bus or by the auto. Okay. So these are the two options that I have. So can I take a bus and an auto at the same time? Obviously not. I can either take a bus or an auto. Okay. So in that case, if I have 5 buses and on the rickshaw stand, on the auto stand, there are 4 autos available. So what will happen? 5 plus 4. So I have an option of 9 ways to by which I can go from the home to the school. Okay. So 5 plus 4. So whenever you read the word and in permutation combination and even in set, it means multiply. And whenever we say or, it means you have to add. This is the mathematical thing. Okay. This is the mathematical thing. Okay. Remember, this is not a grammar class. So whenever I have that, there is an and thing that these things have to be done simultaneously. Then we say you use multiplication. When it is or, that is, have to choose between one or more. Then we say you have to use and. Okay, clear? So now we go to the famous formula for permutations. Just let me see how much have you gone through. Yes, Sneha, thank you, Shriya, Priya. Yeah, very good. Sovan, Muskan, yes, Aditya, Ankit, yes, Vidushi, Nishi, yes, Vani, Tanvi, Palli, Harshita. Okay. Chanchal. Yes, Chanchal, it does consist of the word CA in that example. Yes, Prem, all clear? Exactly. Yes. Yes, Sakshi, you have 1 into 2 into 3. Yes, Bittu, we are going to take the others also. Exactly. Yes. Nishi, you can use ORPET or Oriva calculators. It will not matter. Always remember, okay, this is a very important thing for maths and stats, or rather for the whole of your exam, all of the 4 5 papers that you have, that you use one calculator. Okay. आज बड़े भाई से ले लिया, कल छोटे बहन से ले लिया. Don't do that. Okay. Just have your own calculator that nobody else is using in the house, and make sure that you are using the same calculator. Because sometimes, in the calculators, the plus minus signs are placed differently. Okay. The format in is different, and so you are in the exam mode, you don't see by habit you are using pressing the button and you're pressing the wrong button. Okay, do not buy a new calculator just before the exam. Okay, never do that. Whatever you want to buy started in July itself, get the calculator now. Till December you're going to use the same calculator. Okay, be very careful with that, because I've seen so many students making mistakes. Why? Because then they said, just before the exam I bought a new calculator. Pen and calculators, you must use the same brand of pen, because you have to circle that. So make sure you're used to the same brand of pen, as well as calculator you buy only once, and that's it. Okay, don't change it, and you have to use a simple calculator just with square root and this thing. Yes. Yes, Devansh, once you don't have to worry. Once we start doing the questions, you will find everything will be clear. Okay. Yes, Sahana, I will surely share my CA journey. My CA journey is very interesting, and I'll be doing that afterwards. Okay. See now, as far as possible, don't you can use the one with the tags, but as far as possible, use a simpler one so that you have bigger numbers, so it becomes easier, even when pressing the buttons, it becomes easier. Yes, Ben. Oh, Varni, thank you so much. You've seen my earlier lectures also. Thank you. Krishna, teachers are not changing. Every teacher is allotted certain chapters, okay? So because we are all professionals also, so we have our professional commitments also. So that's why we do that, okay? There are, each subject has 2-3 teachers, and which to whom we are allotted. Yes, Akib, once we do those questions, you will understand when to use permutation, when to use combination. Right now, you should, when we are teaching, don't think about the next thing. Concentrate on this. Make sure you are doing 100 sums on this and get this mastery over permutation. Then you go to combination, get that mastery automatically as soon as you read the question, because it's all about interpretation of what you're reading. We do that in the subject of law, interpretation of statute. So similarly here, you have to just interpret. So for that, the language of the exams, language of mathematical permutation combination and the institute, you get used to it with more and more practice. Most probably, Sahana, I'll get back to you whether this Casio is a good this thing. No problem with that. Okay. I think it's there on the website also, which type of calculators you are allowed to use. Okay. Yes, let's get back to the formula for permutation. So the formula is NPR. Okay. So what in the book you've got this, you could use this formula n into n minus 1 into n minus 2 up to n minus r plus 1, which will produce exactly n factors. Okay. So whenever you have a question, NPR has how many factors? Okay, MCQ, NPR has N R factors. Okay, sorry, not R, N R factors. There is this other formula. NPR is also equal to N factorial upon N minus R factorial. When we solve this, we get this. Okay, which is equal to N into N minus 1 into N minus 2 and so on up to N minus R plus 1. Okay. So, depending on how comfortable you are and which this thing, you can use either of them. But if we have sums where, you have to just cancel out something, then we use this. Okay. So, as you can see, this is in the descending order. N into N minus 1. So, if I have 6, this will be 6 minus 1, that is 5. So, you can see this is in the descending order. So 6, 5, 4, 3, 2, 1, that type of thing. So this is the formula. Now coming to this. NPR is what? We talked about N factorial into N minus R factorial. Now remember to apply BODMAS, which is so important. Suppose I have, 6 factorial upon 6 minus 3 factorial, for example. So some of the students, they use only 6 minus 3 factorial. No, this is what I have to solve this. So this becomes 6 factorial. Numerator, nothing changes. Denominator is 6 minus 3. What is it? It is equal to 3. And then 3 we write. After that we put the factorial sign. Factorial sign is nothing but the exclamation mark. Okay. So this is important. Okay. So if I have suppose 8 factorial upon 8 minus 2 factorial. So this will be equal to what? 8 factorial upon 8 minus 2 is how much? 6. So 6 factorial. Okay. So do remember that. Another extremely important formula is 0 factorial is equal to 1 and not 0. Okay. And not 0. Remember this. This is the game changer formula. 0 factorial is 1. Otherwise, we go around and put it as 0, which is not the case. Okay. npn. Suppose I have 5p5. So this is equal to 5 factorial. Very easy to use, very handy to use in the exam and as it is in practice also. Also, n plus 1 factorial minus n factorial is equal to n into n factorial. See, here there is no factorial. This is simply the number n into n factorial. Okay. See, anytime I have n factorial, I can write this as n into n minus 1 factorial. Okay. N into n minus. You can even put it into. Okay. N into n minus factorial. This factorial is for this n minus 1. So n factorial can be written as n into n minus 1 factorial. Okay. So here what will happen if I want to expand this? Do I have a place here? A little bit. Now n plus 1 factorial can be written as n plus 1 into n factorial minus n factorial. This minus n factorial. Now what is common here? N factorial. So I take this n factorial outside the bracket. What will remain here? N plus 1. What will remain here? Minus 1, because I've already taken n factorial outside the bracket. Minus 1. Now this plus 1 and this minus 1 will get cancelled. This plus 1 and this minus 1 will get cancelled. So what is left is n into n factorial. Okay. So this is how we've got it. But you don't have to know, you don't know where they are going to ask you to prove that, etc. So all you need to do is you need to know that n plus 1 factorial minus n factorial is n into n factorial. Okay. And NPR can be written as n into n minus 1 into n minus 2 up to n minus r plus 1. And also we have n factorial upon n minus r factorial. Okay. So these two formula are the best the most important formula that you will be needing. So now let us dive into some sums to be able to understand. And now I will introduce the concept of the golden rule of factorial, which is so important for you to know. What does the golden factorial rule say is that whenever in doubt, write the whole factorial. Whenever in doubt, write the whole factorial so that you don't make a mistake. Okay, so what is the formula? Let us write the formula here. NPR is equal to n factorial upon n minus r factorial. This is my formula. First sum I take 5p3. First step, which of this is n and which of this is r? Okay. Let us get that thing clear. This on top is my n and this in the bottom is my r. This on the top is n and this is r. Okay. So once I know that, what do I write? 5p3 is equal to 5 factorial upon n minus r. So this will be 5 minus 3 factorial. So BODMAS, I solve the bracket first. So this is 5 factorial upon 5 minus 3, which is 2 factorial. When these numbers are so small, I can write the values directly. Now 5 factorial I already know is 120. 2 factorial I already know is 2. So 120 divided by 2, it is 60. Okay. So when the numbers are small, I will use it directly, no problem. Okay. So what is the value of 5p3? It is equal to 60. Now next is 10p2. Which of this is n? 10 is n. And which of this is r? 2 is r. So this is equal to 10 factorial upon this. What is the formula? N factorial upon n minus r factorial. So 10 minus 2 factorial. Okay. So this is equal to 10 factorial upon 10 minus 2, which is equal to 8 factorial. Clear? Now what do? I don't know 10 factorial. And what if I make a mistake? So what does the golden rule say? That write the numbers, okay? Expand it, write it properly. So this is the golden rule now. Golden rule says, write it down, okay? This will be what? 10 into 9 into 8 into 7 into 5 into 4 into 3 into 2 into 1 upon 8 factorial. Also I am not used to 8 into 7 into 6. Okay, here 6 is remaining. To 6 into 4 into 5 into 4 into 3 into 2 into 1. Okay, initially at least you can do it for practice, once you get the hang of it, because what happens every time in the book you will see directly something is written, or your friend is able to do it and you are not able to do it. Don't worry. At least while practicing, start with this. As soon as you are practicing more and more, you will be able to skip 2-3 steps very easily. Okay, so that is the golden rule. Okay? Just write it down full. Make sure you don't make any mistakes, and after that you will be able to build up your confidence. Okay. Now, I will cancel what is common. 1 is common. 2, 3, 4, 5, 6, 7, 8. Anything else? No, denominator, everything is cancelled. So there is only 1 remaining in denominator. What is happening? This is 10 into 9, which is equal to 90. Okay. One way, golden rule says write it down completely. Another shortcut is from 10 factorial, I will write up to 8 factorial. From 10 factorial, I'll write up to 8 factorial. So this is what? Because I have the formula. Okay, you remember the formula? N factorial can be written as n into n minus 1 factorial. Okay, so using this, I can write this as, this can also be written as 10 can be written as 10 into 9 into 8 factorial. In the denominator, I will write it as 8 factorial. Okay. So 10 into 9 into 8 factorial upon 8 factorial. So what will happen here is this 8 factorial will get cancelled. 10 into 9 is 90. Okay. Understood? One is the golden rule. Second is the shortcut. From the golden rule, once you're very sure of the golden rule, then you can shift to the shortcut, and then you will get the same answer easily. But for that, you should know the concept of factorial very well. Only then you can skip steps and do that. Then what happens is you are able to get the answer. Now the third one is 11p5. 11p5, which is equal to 11 factorial upon 11 minus 5 factorial, which is equal to 11 factorial upon 11 minus 5 is 6 factorial. So I can write it as 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 upon 6 into 5 into 4 into 3 into 2 into 1. Okay, 1 factorial 1, 2 gets cancelled, 3 gets cancelled, 4 gets cancelled, 5 gets cancelled, 6 gets cancelled. So what I have to do? I have to multiply 11 into 10 into 9 into 8 into 7. Okay, so you could do that in the calculator and the answer comes to 55440. Okay, so you could do that. Understood? So once you practice with the this thing, the golden rule, you will not have any problem. NPR is the formula. N is the total number of objects from which we are making the selection, and R is the number of objects we are going to select. Okay. So, or the length of the sequence. What is R? R is the length of the sequence that we want to have. Okay. So what NPR does is, what permutation does is, from the n objects, how many sequences of the length R are we able to form? Okay. What does permutation give us? Permutation gives us that if for n objects, what is the how many sequences of the length R are we able to get? Okay. Yes, Prem, Asha, Sakshi, Venkat Lakshmi, Mansi, clear? Very good, very good. Yes, Shweta, Varun. Yes, Ahmed, diamond rule. You say not golden, it is diamond. Exactly. Yes, I'm not writing with the mouse, I'm writing with the writer. You have this. Okay, this is, can you see this? This is my pen with which I'm writing. Sakshi will be solving as many as possible. Obviously, we can't solve the whole chapter with given the time constraints. Okay. I have uploaded the PDF. So in that PDF, how many sums we are able to cover, I will do it. For each type of sums that can come for the exam, I have covered all of the types. Okay, all the categories, all the types of sums we are considering. So earlier one was sum on the basic formula of permutation. Now we are going to the word problem also, like how many 3-letter words can be formed using the letters of the word square and hexagon. Okay. Now can we count how many letters are there? 1, 2, 3, 4, 5, 6. So that, my n is equal to 6. And how many 3-lettered words? Okay, 3 letters means my R is equal to 3. Okay, n is 6, R is equal to 6. So how many? So what does permutation say, that out of the given n objects, how many sequences can be formed with which have the length as R? Okay, so what do we have? We want 3-lettered words. So my R is 3, and how many letters do I have? That is 6 letters, because I'm considering only the word square. So those will be, how many will be equal to 6p3. So what is the formula? What is the formula? NPR is equal to n factorial upon n minus r factorial. Okay. Remember, every time you are studying, write down the formula. It is okay, the exam is MCQ, but for the formula to register in your brain, you have to write it down. And when you're writing, say it. Okay. Because the audio visual impact of that, whatever you're saying and whatever you're saying will be fit into your mind. Okay. So in your mind, there is this visual memory and there is this audio memory. So in both the memories, when you are trying to remember the formula in the exam, you will be able to tap into this, because in both the memories, this formulas will be fitted. Because when you are writing, you are having a visual impact of your writing n factorial upon n minus r factorial. And as you are speaking, the audio memory is also created. So 6p3 will be what? 6 factorial upon 6 minus 3 factorial. Solving the denominator first, this is 6 factorial upon 3 factorial. Okay. Now I may write this as how much? 6 factorial is 720 upon 3 factorial is 6. So I get the answer 120. But we are also going to use the golden rule. Why? Because this topic is new to me. So 6 factorial can be written as 6 into 5 into 4 into 3 into 2 into 1. And what is the denominator? 3 factorial. So 3 into 2 into 1. So what should I do? I should cancel. So 1 cancels, 2 cancels, and 3 cancels. What am I left with? 6 into 5 into 4. So this is 6 into 5 into 4. 6 5s are 30. 30 into 4 is 120. Okay. So both these answers are the same. Okay. So you can use either of them. Now, similarly, you have hexagon. How many are there? N is how much? 1, 2, 3, 4, 5, 6, 7. R is how much? I want to form 3-lettered words. So this is 3. So N 7CR. Okay. So what happens here is this much. 7PR. So 7P3. So this is 7 factorial upon 7 minus 3 factorial. 7 factorial upon 4 factorial. So this is 7 into 6 into 5 into 4 factorial upon 4 factorial. Okay, so I could use this. 4 factorial gets cancelled. 7 into 6 into 5. So that is 6 5s are 30. 30 into 7 is 210. Okay. Golden rule. 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1 upon 4 factorial is 4 into 3 into 2 into 1. 1 cancels, 2 cancels, 3 cancels, 4 cancels. So you are left with 7 into 6 into 5. Okay, 6 5s are 30, 37s are 210. Yes. Okay. Yes, Srishti, everything is clear? Vani, Anant, Madashu, and all the others who are asking about weightage, you can see the weightage PDF is already there on the website, so you can see that. Okay, for all the chapters you will be able to see. Yes, Palak, clear up till now. Akruti, Mrunalini, Sahana. Yes, Sahana, it's a stylus. Teja. Okay, yes, Teja, I can even show you with that. No problem. So, So I have 6p3. So what is the formula? The other formula is n into n minus 1 into n minus 2 up to how much? N minus r plus 1, right? Now what is n here? N is 6. What is r? 3. So first we will calculate this. How much is n minus r plus 1? 6 minus 3 plus 1. How much is this? 6 minus 3 is 3. 3 plus 1, which is equal to 4. Okay. So what does it mean? I have to go from n is 6, from 6 to 4. So what will this be? This is equal to 6. 6 minus 1 is how much? 5. And 6 minus 2 is how much? 4. So what is the last number I should have? It is up to 4 into 4. 6 5s are 30. 30 into 4 is 120. Clear? Okay. We got the answer as 120. So you can use any formula. You will get the same answer. Okay. Is Teja clear? Yes, Mansi, I've shown with the second formula also. Asha? Yes, you've understood? Very nice. Saunak, Komalpreet, Dhruv, Shweta, Raj, Bipita, Saurabh, Mrunalika. Oh, nice name. Palak, Harshita, Suhani, Prayukta. Why 249 Prayukta? No. Yes, Raj, you can cancel 3 factorial directly. Once you, like some of you have already studied, so it's easy for you. But for those who are doing it in the first time, the factorial can be very overwhelming and confusing also. So in that case, follow the golden rule. जो नंबर दिया है उससे उस तक हमें 1 से लेके उस नंबर तक जाना है बस, या उस नंबर से 1 तक आना है, नीचे जाओ या ऊपर जाओ, कैसे भी जाएंगे लेकिन वो इजी रहेगा अपने को. Satya, you got it? Khushi? Yes, thank you. Doesn't matter, Sonak. This is the place where you can give answers, which even if we go wrong, no negative marking here. Okay, so it's good that we make mistakes here rather than the exam. Yes, Yash will be doing those type of, yeah. Yes, Anand, all clear? Old papers are not available, but you can, the mock papers are available. So you could start solve them after you're finished with the syllabus. Till now, what you have to do is you have to take the thing. Whatever is given in the study material, you should be able to first solve that. So don't jump. Once you finish with the study material, go to the mock. Then you have the model test papers. You have the big bunch of papers, so you could solve that also. So let us go to the next question. Yeah, I'll see which sum you want. Most probably I'll be covering that also. First, second, and third prizes are to be awarded at an engineering fair in which 13 exhibits have been entered. How many different ways can the prizes be awarded? So how many exhibits are there? How many people are there who are eligible to get prizes? So how many are there? That is n. N is equal to 13. How many prizes are there? Out of these 13, how many people have to get prizes? 3. So my R is 3. Okay. Obviously, if one person is getting the first prize, will he be able to get the second prize? No. So what happens is that he will automatically be not there. So somebody else will get the second prize. So that means this is a question of permutation. Okay. Somebody, Akib, I think, was asking, when do we know it is permutation or combination? So see, in this sum, can any person get all the three prizes? You know, in the normal case, nobody gets, one person is getting all first, second, third. Right? So one person will get the first prize, then another person will get the second prize, another person will get the third prize. So order is important, right? I cannot have the same person getting a prize over and over again. So then in this case, we are using the permutation. So what will this be? NPR is equal to n factorial upon n minus r factorial. Okay. So I will have 13p 13p3 is equal to 13 factorial upon 3. Oh, sorry, 13 minus 3. Just a minute. Thirteen factorial upon 13 minus 3 factorial. So this is equal to 13 factorial. I solve the denominator, that is the bracket first, 13 minus 3, that is equal to 10 factorial. Okay, using the golden rule, I go from 13 up to 10. So this is 13 into 12 into 11 into 10 factorial upon 10 factorial. Okay, so I could do that. Okay, so this 10 factorial and 10 factorial get cancelled, and I'm left with 13 into 12 into 11, which is equal to 1716 ways. Okay. This is one way of doing it. Second way of doing it is that I write it, this is equal to 13 into 12 into 11 into 10 into 9 into 8, 7, 6, 5, 4, 3, 2, and 1 upon 10 factorial is 10 into 9 into 8 into 7, 6, 5, 4, 3, 2, 1. Okay. So 1, 2, these get cancelled. 4, 5 get cancelled. 6, 7, 8, 9, and 10. So what are we left with is 13 into 12 into 11, which is 1716. Okay. The third way of solving this is NPR is equal to n into n minus 1 into n minus 2 up to n minus r plus 1. Okay, so how much is n minus r plus 1? N minus r plus 1 is, how much is n? 13 minus 3 plus 1, which is equal to 10 plus 1, which is equal to 11. So from 13, n is 13, up to where should I go? Up to 11. So 13, then 12, and where should I go up to? Up to 11. Okay, so up to 11. So this is also equal to 1617 ways. Okay, first, second, and third. Any of these three methods are perfectly all right, and you can use any of these methods. Clear? Yes, got it, Sneha? Okay, Jia, you've done till example 5. Excellent. Okay, yes, Amit, there is a little issue. Page number that I've written in the PPT, by mistake I used the old study material, so maybe the page numbers may not match, but you get page numbers near about there. Okay, so sorry about that, because I think all of you are referring to the new study material, whereas the material that I use while putting the page number, there has been a slight difference. Okay, yes. Sakshi, how do we remember the mass formula? Is that okay? Very important question, and you should do it right now itself, that you make a notebook, okay? A thin notebook, but it should be hardbound because you'll be using it every day. So hardbound notebook you should make, and in that write down the formula for each and every chapter. Okay, write down the formula. As soon as you've studied that chapter, write down all the formula from that chapter. Okay. Every night before you go to bed, for 15 minutes, you're going to write down all the formulas that are there in that notebook. You're going to read the formula and you're going to write it. And then nobody can stop you from getting more than 60% in the mathematics. Okay. So you should do that, and it becomes so, because you every day you're seeing all the formula from all the chapters. As you are studying each chapter, you are not going to study only that chapter's formula. Other formula also you're going to study. And so what happens, anytime you start revising, all the formulas are already there in your head. Okay, Sakshi? Yes, Roshan, we are going to move to the next one. No doubt. Okay, we'll be taking a break at 3 p.m. Priya Kumari, how do you understand which is N, which is R? You should see from which collection are you going to take the small collection. Okay. Normally N, what is the important thing? N is always greater than or equal to R. N is always greater than equal to R. Okay. So N will be the bigger number, or at least both the numbers will be equal. Okay. You cannot have N less than R. Yes. Vidushi, Asha, Morgan, Priya. Yes. Excellent. Okay, Saloni, very good. Now, in how many ways can 5 people stand in a line for a group photograph? Very good, Saloni and Saurabh, they have already answered. So, 5 different numbers. How many? N is how much here? N is 5. How many different ways can 5 people stand in the group? This is what I was talking of. Out of these 5 people, how many people are standing for the photograph? All of them are standing for the photograph. So R will also be 5. Okay. R will also be 5 because there are 5 people and all of them want to stand in the for the photograph. So this number of ways they can stand for a photograph is equal to NPR, which is equal to 5PR. Okay, which is 5P5. Because N is also 5 and R is also 5. So 5P5, which is equal to 5 factorial upon 5 minus 5 factorial, which is equal to 5 factorial upon 0 factorial. Okay. Now, very important here, I must remember that 0 factorial is equal to 1. Okay. I must remember that. And so this becomes 5 factorial upon 1. 5 factorial I know is 120. So in 120 ways, 5 people can stand for a photograph in 120 ways. Okay. Also, you must remember that you could have easily written this because NPN is equal to N factorial. Okay. This is also a formula. I think I've written it in the slide. Yes, see this NPN is equal to n factorial. So if you remember all these formulas, then you can easily apply them. Okay. So for that, that's why it's important, as Sakshi was asked me. So what is the important thing that we should do is that we should be able to remember those formula. And how do I remember? If I'm writing in them down every day. So the moment I write 5p5, I should remember npn is n factorial. So I should be able to write npn. I could write it as directly as 5 factorial and get the answer as 120. Okay. So one sum before we take the break. Example 5. In how many different ways can 3 students be associated with 4 chartered accountants, assuming each chartered accountant can take at most 1 student? Okay. So each chartered accountant can take at most 1 student. So N is 4, R is 3, NPR is equal to 4P 3, which is equal to 4 factorial upon 3 factorial. So this is equal to how much? Oh, what? 4 factorial upon 4 minus. So this is 4 minus 3 factorial. What is the formula? N factorial upon n minus r factorial. So 4 factorial upon 4 minus 3 factorial, which is equal to 4 factorial. 4 minus 3 is 1 factorial. What is 1 factorial? Is equal to 1. So this is equal to 4 factorial upon 1, which is equal to 4 factorial. 4 factorial is golden rule, 4 into 3 into 2 into 1. 4 3s are 12, 12 2s are 24. So that is 24 ways in which 3 students can be accommodated with 4 CS. Okay. Can we take a break now? Let's see. Afak? Welcome back after this short break. Yes, let's see. Okay, let's do the next sum. So this next sum, you remember the chapter on ratio and proportion. So in that case also, there was word problems. So the word problems is a thing that some of the students get a little worried about. But what you must remember is we just have to convert the English into maths. Okay, keep an open mind, do it, and you will see that maybe one sum, two sums, you may not get the hang of it. You may write a incorrect equation, but it is okay. It is okay. You should be able to forgive yourself and try. Just some students, they see a word problem and they freeze. That should not be the case. Maths is something that is talking to you. It's very clear. Once you are able to understand what you're supposed to write, it's very clear. So for that, what is necessary is practice. P. That is practice. Okay, nothing more than that is required of you. So now we are doing this word problem. As promised to you, I am taking every type of problem, that is clear NPR problems, clear word problems, and clear sums in which you just have to read and you have to just write it out. But here, this is a word problem that you should be able to understand and put it into a mathematical equation. Okay. So if 6 times, okay, so what are the important words I should be careful about? Now, if 6 times, what does times indicate? Multiplication. The number permutations of n things taken are at a time. So the number permutations of n things are at a time. So permutation of what? N things taken are taken 3 at a time. So not R3. So what is n here? This is my n. N is n. And what is my R? 3. What is the sequence length I want is 3. So R is 3. So sequence length R is 3. What is N? N is what the value I don't know. So this will be NP3. Okay. If 6 times, that is multiplication, 6 times, so 6 into NP3 taken R at a time is equal to, wherever, write it down there itself in the question paper. To 7 times, again the word times is coming. So 7 into the number of permutations of n minus 1 taken 3 at a time. So what is the sequence length R? R is 3. What is n here? N is n minus 1. What is the question? Question is n is equal to how much? Right? So I have got this. I'm going to write down the mathematical equation for whatever is given in this word problem. So 6 times. So what is this? This is n minus 1 p3. Okay. So now what is the equation? 6 multiplication np3. So 6 into np3 is equal to what? Is equal to 7 into n minus 1 p3. Okay. This is how your equation will look like. 6 into np3 is what? N factorial upon n minus 3 factorial. 7 into n minus 1 factorial upon n minus 1 minus 3 factorial. Okay. Now, if I remember the formula, excellent. If I not, I will follow the golden rule. Now, what is n factorial can be written as n into n minus 1 factorial. N minus 1 factorial. There is a factorial here. Okay. So n factorial can be written as n into n minus 1. Why do I want? Because on the RHS I can see this n minus 1 factorial. So 6 into n minus 1 factorial. Now what is this? This is equal to 7 into n minus 1 factorial upon what? N minus 1 minus 3 is n minus 4 factorial. So instead of n minus 3 factorial, I can write it as n minus 3 into n minus 4 factorial. Instead of n minus 3 factorial, I can write it as n minus 3 into n minus 4 factorial, which is equal to 7 into n minus 1 factorial upon n minus 4 factorial. Okay. Now, what do I do? Here, n minus 1 factorial will cancel with n minus 1 factorial, and n minus 4 factorial will cancel with n minus 4 factorial. So I can get this as what is remaining in on the LHS? 6 into, no, not into, 6 upon. In the numerator, I only have 6 in the 6 into n. Okay, yes. 6n, and in the denominator I have n minus 3. Okay, and here I have equal to 7. Okay, because n minus 1 factorial has also cancelled and n minus 4 is also cancelled. Cross multiply, I get 6n to be equal to 7 into n minus 3, which is equal to 6n into 7 into n, 7n, 7 into 3, 21. So minus 21. So this 21 I take to this side and 6n I take to this side. So this I take here and this I take here. When a number crosses the equal to sign, its sign changes. So this will become 7n minus 6n, which is equal to 21, or n is equal to 21. Okay. So this is one way of doing it. Now we will do with the golden rule method. I'll just write this. This is 6 into np3 is equal to 7 into n minus 1 p3. Okay. So golden method, 6 into n factorial upon n minus 3 factorial, which is equal to 7 into n minus 1 factorial upon n minus 4 factorial. Okay. This is the simple way. So what do? I will write this as 6 into n factorial. I can write it as n into n minus 1 into n minus 2 into so on up to 3, 2, 1 upon n minus 3 factorial. I can write it as n minus 3 into n minus 4 into n minus 5 up to 3, 2, 1. Okay. Here I can write it as 7 into n minus 1 factorial will be n minus 1 into n minus 2 up to so on 3, 2, 1. In the denominator, n minus 4 factorial is there. So n minus 4 into n minus 5 up to 3, 2, 1. Okay. Now I only have to see what is going to get cancelled. Can you see here from n minus 1 up to 3 to 1? So n minus 1 up to 3 to 1 is there. In the denominator, n minus 4, n minus 5 up to 3 to 1. So n minus 4 is there. I can cancel this. Okay, this is going to cancel with this, and this is going to cancel with this. Okay, so what am I left with here? 6n upon n minus 3 is equal to 7. Okay, use either of the method, you will get the same answer. N is going to come to 21. N minus 4, they have, see here, Saurabh, this is n minus 1 minus 3. What is the formula NPR? NPR says, NPR formula is n factorial upon n minus 1, n minus r factorial, right? Here what is happening, instead of n, what do I have? I have n minus 1. So that is why this formula becomes, this is n minus 1 PR. So this becomes n minus 1 factorial upon n minus 1 minus r factorial. Okay. So here n minus 1, what is r here? R is 3. Okay. Saurabh, is that clear? Same formula here, Saurabh. N factor. This is the formula we are using. N factorial is equal to n into n minus 1. So n minus 3 factorial will be n minus 3. N minus 3 minus 1, that is equal to n minus 4. Okay. Shazia, again, I'm telling you, there is a PDF uploaded in the ICI Foundation website. So there you will be able to see the weightage of all the subjects or all the chapters. Okay. Okay, that is why Anand also, that's what I'm saying. If you find this direct formula difficult, go in for this. Okay, this is easier. At the start, when you're trying to study the subject topic, you should use this. Okay, once you have mastered this, you can go in for the earlier one. So that is why I'm telling you about this whole thing. Yes, Amit, I'm left-handed. Yes, thank you. Yes, Satya, you understood? Are Satya? Yes, Venkat Lakshmi, you've understood. Akruti. Yes, Akruti, I'll explain again. Others have understood? Yes, please put it in the chat box. This formula you have understood? Okay, simple. Because I have 6 into n factorial upon n minus 3 factorial and 7 into n minus 1 upon n minus 4 factorial. Here we are using n minus 1 PR will be equal to n minus 1 factorial upon n minus 1 minus r factorial. Okay, so this n factorial, this np3 I have written like this, and n minus 1 p3. So here what is happening is n minus 1 p3 I have here on the right hand side, which is equal to n minus 1 factorial. In the denominator, this is n minus 1 minus r. So n minus 1, what is r? R is 3, so minus 3 factorial. जगह नहीं है factorial के लिए. Okay, so that is why this becomes, I'll write it here, n minus 1 p3 can be written as n minus 1 factorial upon n minus 1 minus 3 factorial. Okay, from this. So this becomes n minus 1 factorial upon n minus 1 minus 3 is minus 1 minus 3 becomes minus 4. Simple. So this becomes n minus 4 factorial. Okay, hope everybody of you have understood. So same sum, I have solved it in 3 different ways. Whichever you are able to understand, do that. Okay, very good. Varun, Priyanka, Shrestha, Utkarsh, Apurva, Roshan, Mansi, Asha, Satya, Akruti, Venkat Lakshmi, yes. Vidushi, Raj. Thank you, Raj. You feel the methods are easy. Very good. Yes, Yamini, Anand, Gautam, Mohammed, Saloni. Okay. Yeah. Let's go to the next example. Compute the sum of 4-digit numbers which can be formed with 4 digits 1, 3, 5, 7. Okay, if each digit is used only one. See, sometimes what happens, there is a lot of other information is also given if each digit is used only one. So normally for you, the sums will be simply that we are using it only once. Even though they've written specifically, those complicated sums are not there in your syllabus. Okay, so you could do this. Okay, I would really want you to solve this sum on your own and then you could come back and in the next lecture. So let me know whether you are able to solve this and get it done. Okay, if not, we'll take it in the next lecture. Now let us do this. These are the type of sums that you do get in the exam. So find n if np3 is equal to 60. So this type of sum tests whether or not you know the mathematical way in which permutations are expressed, you know. So np3. So what is the formula that we have? Okay, we have two formula for that. NPR is equal to n factorial upon n minus r factorial, or you even have this to be equal to n into n minus 1. Up to where do you go? N minus r plus 1. Okay. Now, if I have this np3, what is r? R is equal to 3. Okay, so I have np3. So I can either write this as n factorial upon n minus 3 factorial, or I can use a second formula. So I will show you by both the methods. Okay. So np3 can be written as n factorial upon n minus 3 factorial. N minus 3 factorial. So how much is this? I will write n factorial up to n minus 3 factorial. So n into n minus 1 into n minus 2 into n minus 3 factorial upon n minus 3 factorial. Okay. So this n minus 3 factorial will get cancelled. I know np3 is how much? It is given to me equal to 60. So 60 is equal to how much? N into n minus 1 into n minus 2. What does this mean? It means that 60 is a multiplication of 3 consecutive numbers. Here n into n minus 1 into n minus 2 means what? There are 3 consecutive numbers like 6, 5, 4. No, that type of thing. Now let us see the factors. How can I write 60 as a factor of 3 numbers? 60 into 1 into 1. I can write it as 30 into 2 into 1. But as you can see, none of these are consecutive numbers. So I can write this as 15 into 4 into 1. But this is not going to solve my purpose. So I can also write this 60 as 6 into 5, that is 30 into 2. 32 is a 60. But I will not get still the answer. So what I have to do is, I'm quite near. So I will write 5 into 4 into 3. 5 4s are 20. 23 is a 60. Right? Are they consecutive? Yes. So first I have to check whether the multiplication is giving me 60. Yes. Then I should check whether this number are they consecutive? Yes. Okay. Otherwise, you could write this as a cubic equation and solve. But why complicate? Yes. So you could do that. Second second shortcut I want you to do is just see in the options. From the options also, you will be able to find this. Okay. So how much is this? So how much is n? What is the biggest number? 5. So n is equal to 5. Okay. Can I cross check now? Let us cross check. How much is 5p3? 5 factorial upon 5 minus 3 is 2 factorial. How much is 5 factorial? 120. How much is 2 factorial? 2, which is equal to 60. Okay. So this is the way I could do that. Let me show you by the second formula also. How much is n minus r plus 1? Just let me change the color also. How much is n? N is this much. N. R is how much? 3. 3 plus 1. How much is this? Minus 3 plus 1 is minus 2. So this is equal to n minus 2. So that np3, I'm using the second formula. I have to go from n into n minus 1. Up to where I have to go? I have to go up to n minus 2. This is equal to n into n minus 1 into n minus 2. Same formula I've got, n into n minus 1 into n minus 2, and you have to solve this and get this as the answer. Next sum. Shrestha, which example? Fifth example. This is clearly this way, na? That 4 CS are there and 3 students are there. Okay. Dimelo, it's not confusing. You have to like do these sums. Also 7 sum. Doesn't matter. Try it. And then next time I will do it for you. Okay. But if you do it, you are able to do it. See the amount of boost it is going to give to your confidence, right? Then you will be able to get the feeling that yes, I can tackle any difficult sum also that is coming my way. Okay. Try to do it so that your solution is present in front of you when I solve it for you. Okay, then you'll know, oh, I made a mistake in this step. Otherwise, all the steps are correct. That will help you to get your confidence. Okay. Yes, Mansi, Saloni, Komalpreet. Yes. Ruby. Ruby, N is not 2. N is 5. Yes. Options help you most of the times, but sometimes what happens is that the correct option is the last option, and then you're spending time in putting the options, trying to do the calculation, and sometimes because it's exam time, I'm trying to do the number crunching, and by mistake I press a number twice and I get a wrong answer. Okay, or I don't get an answer and I panic. So most of the time, if it is easily doable, fine. If not, if you're short of time, it is better to solve it Then see here what is simply 60. I can once I've written one time 5 into 4 into 3. Next time you get a 60, you will automatically write n is equal to 5, right? So that is helpful as far as possible during practice. During your studies, you should use this formula and do the sums. And then when you're practicing the whole thing last, then you use the shortcuts where you're using the options and then doing it. Seeing the option, taking the value of n and putting n as 5 and doing it, it's completely okay. Okay. But you should know the answers also. Here also, see what will happen. You will substitute r. There will be so many r's and then you will substitute them. So here also the shortcut is that see what the options are available, put them in the values and see which of them is giving you 30,800. Okay. So that is also a valid option. But I will show you the method and then we will see. 56p r plus 6 is equal to, what is the formula? NPR is equal to n factorial upon n minus r factorial. Okay. So this is 56 factorial upon 56 minus r minus 6 factorial. Okay. Remember there is a plus sign which when you put it after the minus sign, it will become minus. So this minus sign is very important. By mistake, don't write plus. So this is equal to 56 factorial upon what is this? 56 minus 6 is 50. So this is 50 minus r factorial. Okay. 56 minus 6 is 50. Then 54 p r plus 3 will give you 54 factorial upon 54 minus r minus 3 factorial, which is equal to 54 factorial upon 54 minus 3 is 51 minus r factorial. Okay. Now this upon this is equal to this upon this. So I will write this as 56 factorial upon 50 minus r factorial upon 54 factorial upon 51 minus r factorial is equal to 3800 upon 1. Okay. Now I cross multiply because I don't want a fraction in the denominator also. So what do I get? So this will become 56 factorial upon 50 minus r factorial is equal to 30,800 into 54 factorial upon 51 minus r factorial. Okay. Now important, please pay attention. This number 56 number I am going to write up to 54 number and 51 minus r factorial I am going to write up till here. Okay. So this is equal to how much is this? 56 up to 54. So I will write 56 into 55 into 54 factorial. Denominator same thing, 50 minus r factorial. Bigger number up to smaller number I will write. This is equal to 3800 into 54 factorial. I will remain as it is. Okay. Now this is the bigger number to smaller. 51 minus r factorial can be written as 51 minus r into 50 minus r factorial. Okay. Why? Because n into n minus 1. So what will it be? Okay, if you want, I will put this one more step here. You know that n factorial can be written as n into n minus 1 factorial. So here, what is n? N is 51 minus r. 51 minus r minus 1. Okay. 51 minus r minus 1. What is 51 minus 1? It is 50. Okay. So this is equal to 3800 into 54 factorial upon, what will this be? This is 51 minus r as it is. And 51 minus 1 is 50 minus r. 50 minus r factorial. Okay. Now this 54 factorial and this 54 factorial will get, not here, sorry. This 54 factorial and this 54 factorial will get cancelled. In the denominator, 50 minus r factorial and this 50 minus r factorial will get cancelled. So what will remain? This is from here 56 into 55. This 54 factorial has cancelled and 50 minus r factorial has also cancelled. So 56 into 55 is equal to 30,800 upon 51 minus r. Okay. So I have this much. So what do I do? Now I have 51 minus r is equal to 3800 upon 56 into 55. Okay, 56 into 55. So if I solve this, how much will I get? This comes to 10. So I have 51 minus r is equal to 10. I take this minus r, this side it becomes plus r, this plus 10, taking it this time becomes minus r. So I will get r is equal to 51 minus 10. So this is equal to 41. So r is equal to 41. As soon as this session gets over, take the sum, completely try to do it on your own. Once you will do it on your own, you will be so confident. Take a bigger paper and write it down completely, and then you will see you will be able to do it. If not, go back to the video, see again, and then go back. You may need 2 times, you may need to see the video 2 times. See the video 2 times, okay? And then you will be able to see this. Okay, so R is 41. Let me explain again. Whenever such types of sums are given, you have to simply stick to the formula. Don't vary from the formula. So NPR is n factorial upon n minus r factorial. What is n? N is the total number of objects from which we are forming sequences. The sequence length is how much of the length r. Okay, that is the basic formula for n permutation. Here, what do I have? Instead of r, I have r plus 6. Okay, here I have, instead of r, I have r plus 6. And here I have r plus 3. That does not change the formula. Instead of r, I'm going to write r plus 6. Instead of r, I'm going to write r plus 3 in the RHS. Okay, just write down the formula and then cross multiply so that it becomes easy for you to solve, and then you will be able to do it. Okay. So purposefully I've taken the difficult sum so that your confidence is able to rise. Yes, Asha, you're most welcome. I will give you as many tips as I can. Chavi, yes, okay, I'll just see where I have some place. I will solve this again. Okay, here I have place. Okay. Can you see this full sum? Yes, Sakshi? Okay, Sakshi, you can also go back to the YouTube channel. These videos available on the YouTube channel if some of you don't know that. and there you can watch them again and again. So some of the earlier students are also there, some of the new students are there who have seen my earlier videos also. Okay, so you can go to the YouTube channel, just select the batch number, earlier batch number, and you will see all the videos are already there. And so you can go through those videos, and then you will be able to, when we are solving these sums again, you will have double practice. Okay, yes, Vani. Thank you for your emojis. Yes. So, Shaunak? Yeah. Satya, crystal clear? Priyanka? Yeah. Okay, I'll just show this again. 56p r plus 654. So this is, I'm just repeating the sum. So what do I have? 56p r plus 6 is to 54p r plus 3 is equal to 3800 is to 1. I will first consider 56p r plus 6. Using the formula npr is equal to n factorial upon n minus r factorial. I have this to be equal to 56 factorial upon 56 minus r minus 6 factorial, which is equal to 56 factorial. 56 minus 6 is 50. 50 minus r factorial. Okay. 54p r plus 3 is going to be equal to 54 factorial upon 54 minus r minus 3 factorial. 54 minus r is 54 factorial upon 51 minus 3 factorial. Now, what do I do is this I will write. So this is equal to 56 factorial upon 50 minus r factorial upon 54p r plus 3 is 54 factorial upon 51, not 3, 51 minus r. 51 minus r. 54 minus 3 is 51, 51 minus r. Okay, is equal to 30,800 upon 1. I cross multiply, I take this to this side, this becomes equal to 56 factorial upon 50 minus r factorial is equal to 30,800 into 54 factorial upon 51 minus r factorial. So here I identify which is the bigger number. Here this is the bigger number and here this is the bigger number. Okay. 51 minus r is bigger than 50 minus r, obviously. And 56 is bigger than 54. So what I do, I write from the bigger number up to the smaller number. So this becomes 56 into 55 into 54 factorial. Okay. Upon 50 minus r factorial is equal to 30,800 is just a number. I'll write it like this. 54 factorial, I will also write it like this. In the denominator, this is the bigger number. So 51 minus r up to 50 minus r. So what is n into n minus 1 factorial? So how much is n? 51 minus r is n. And then you will have 51 minus r minus 1 factorial, which is equal to 30,800 into 54 factorial upon 51 minus r into 51 minus 1 is 50. So this becomes 50 minus r factorial. Okay. So what are going to cancel? This 54 factorial is going to cancel with this 54 factorial, and this 54 minus r factorial is going to cancel with this 54 minus r. So what are you left with on the LHS? Left hand side 56 minus 55, and on the RHS this is 30,800 upon 51 minus r. And when I solve this, I get r is equal to 41. Okay. So now have you got the answer? Yes. I hope everybody has understood now. Quickly, let us go to the next sum. Okay. In this, we have already talked about this. In this, what are r? The number of factors is r. Okay. Okay. In NPR, the number of factors is r. That is a theory question. Somebody was asking whether or not we get theory questions. Yes. These are the type of theory questions you get. Now NP4 is equal to 12 into NP2, then N is equal to how much? Earlier sum, similarly you have to apply over here. Okay, same type of sum. NP4 is equal to 12 into NP2. How do I expand and what do I get? NP4 is n factorial upon n minus 4 factorial is equal to 12 into n factorial upon n minus 2 factorial. Okay. So n factorial will get cancelled out. Now n minus 4 and n minus 2. So what do? I will write them from n minus 2 up to n minus 4. Okay. So this n minus 2 factorial can be written as n minus 2 into n minus 3 into n minus 4 factorial. Okay, it just increases n minus 2, n minus 3, n minus 4 because it is minus, so number is decreasing. And here up till where should I write it? Till n minus 4 is reached. So I have one upon n minus 4 factorial to be equal to 12 upon, instead of n minus 2, what will I write? This. So this is n minus 2 into n minus 3 into n minus 4 factorial. So this n minus 4 factorial will get cancelled. Okay, this n minus 4 factorial will get cancelled, and what is remaining is left hand side, nothing is there. So 1 is equal to 12 upon n minus 2 into n minus 3. Cross multiply, I have 12 is equal to n minus 2 into n minus 3. Okay. Which means what? 12 is, what are the factors of 12? There are two numbers which are consecutive. And we know the factor of 12. 12 can be written as 4 into 3. So which is equal to 4 into 3. So 12 is equal to 4 into 3. Which is, so what is this? N minus 2 is equal to 4. N minus 2 is equal to 4. And n minus 3 is equal to 3. N minus 4 is 4. N minus 2 is 4. So n is equal to 4 plus 2, which is equal to 6. Okay, so what will this be? Ninth sum, what is the answer? N is equal to 6. Option B is the correct answer. Yes. Okay. In how many different ways can a club with 10 members select a president, secretary, and treasurer if no member can hold two offices and each member is eligible for any office? So N is how much? N is 10. Okay. A person cannot be president as well as treasurer. So you have 10. And how many positions are there? R is equal to 3. So So how many different ways to get a president, secretary and treasurer will be equal to 10 PR, which will be equal to 10 P3. So this is equal to 10 factorial upon 10 minus 3 factorial. How do I get that? Because NPR is equal to n factorial upon n minus 3 factorial. So this is equal to 10 factorial and 10 minus 3 is 7 factorial. So golden rule method, 10 into 9 into 8 into 7, 6, 5, 4, 3, 2, 1 upon 7, 6, 5, 4, 3, 2, 1. Okay. Cancelling 1, 2, 3, 4, 5, 6, and 7. So 10 into 9, 90, and this becomes equal to 720. And if I use this 10 factorial, this is can be written as 10 into 9 into 8 upon into 7 factorial upon 7 factorial. So this 7 factorial get cancelled again 720. Okay. I must talk to you about circular permutations. The circular number of circular permutations of n different things chosen at a time is n minus 1. So if I have a circle and say suppose like these, I have to like suppose I have a round table and I have to make people sit around a round table. And how many different ways can I do that? It is equal to n minus 1 factorial ways. Okay. So like if I have 5 people, then I can make them sit around 5 minus 1, 4 factorial ways. So 4 factorial is 24. So 24 ways in which I can make 5 people sit around a circular table. Now, when it comes to necklaces, because people are you can identify, but necklace what happens is that the front portion and back portion, like in case of beads, okay, we are talking about in case of beads, not like gold jewelry, we're not talking about those necklaces. We are talking about necklaces made of beads. Bead mane moti. So those are circular, okay, those are spherical rather, and so they do not have a front side and the back side. So in that case, what is happening is this half is very important. In that case, number of necklaces you can form with the beads is equal to 1/2 into n minus 1 factorial. Okay, so this is important. And the number of ways of arranging n persons along a round table so that no person has the same two neighbors is again the same. So the necklace formation formula and the formula for arranging a person so that arranging a person along a table such that no person has the same neighbors is also 1/2 n minus 1 factorial. Okay. So this is very important formula. Let us do certain sum. So what is the number of ways for circular permutation is equal to n minus 1 factorial ways. So in how many ways can 4 people sit around a table for group discussion? 4 people will be equal to 4 minus 1 factorial. 4 minus 1 is 3 factorial. 3 factorial is 6 ways. Okay. Simple, right? Only you should know the formula for circular. The number of ways in which 7 girls form a ring is 7 girls. Formula is n minus 1 factorial. So 7 minus 1 factorial, which is equal to 6 factorial, which is equal to 720 ways. Okay. Okay. Now this sum. The number of ways in which 7 boys sit around a round table so that 2 particular boys may sit together. Okay. So what happens is I have B1, B2, B3, B4, B5, B6, B7. Now what happens is these two want to always sit together, may sit together is. So what does this mean? This means as if we have a one big boy. Okay. So I can have, that means this is B1, B2, B3, B4, B5, and this I can say as X6. Okay. So how many people are there? 1, 2, 3, 4, 5, 6. As if these two are sitting together on one chair. No, that type. But that is only there for our understanding. So what will happen? This is 6 people sitting around a round table. As good as 6 people sitting around a round table, that is n minus 1 factorial will be how much? 6 minus 1 factorial, which is equal to how much? 5 factorial, which is equal to 120. Okay. Now, but what happens is these two boys can sit as B6, B7 or B7, B6. Okay. They can sit in this order. So what will happen is total number of ways the 7 boys can sit will be equal to 120. This 120 into this is how many? 2 ways into 2, which is equal to 240 ways. Okay. Because 120 ways in which 6 boys can sit around a round table. But because one of the boys is not a single boy, it is a combination of 2 boys. So these 2 boys can sit as 6, B6, B7 or B7, B6. So as good as one big boy sitting in the chair, but at inside there are 2 boys sitting. So it is B6, B7 or B7, B6. So how many different ways can the 2 boys sit? 2 different ways. So 2 into 120, that is 240 ways. Okay. The L symbol is also there for factorial. Okay, so you can write it as, like I write it as 3 factorial. You can also write this as 3. Okay, this means also factorial. Okay, so L symbol is for factorial. Okay. Yes, Pali, Harshita, I will upload some assignments also. Okay. Yes, Chanchal, crystal clear? Yes. Yes, Simran, there will be negative marks. Purva, you don't reduce n minus 4 to n minus 2. N minus 2 is a bigger number. See, okay. Suppose I have n is equal to 10. How much will n minus 2 be? 10 minus 2, which is equal to 8. How much will n minus 4 be? 10 minus 4, which is equal to 6. Which is bigger? N minus 2 is a bigger number. Understood? Yes, Rishti, very good. Okay, so many of you answered correctly. Excellent. Yes, now it is clear. Yes, I'm trying to cover, Mohammed, as many as possible. I try to cover. But no point in rushing into things, you know. Okay, now here 50 different jewels can be set in the form of a necklace, then the number of ways will be how much? Okay, so you know that bead necklace is equal to 1/2 bead necklace is 1/2 into n minus 1 factorial. Okay, so here they just want to see whether or not you know the formula. So these are, you know, really very good sums to score marks, and then you could use that time to solve the bigger sums. So how much is n? There are 50. So this is equal to 1/2 50 minus 1. How much is 50 minus 1? 49. So which is equal to 1/2 into 49 factorial. So because they use the symbol like this is equal to 49 upon 2. So B will be the correct answer. Okay, I just want you to know this. Okay, the number of permutations of n distinct objects taken are at a time when a particular object is not taken in any assignment is n minus 1 PR. Okay, so you have n objects. Suppose you have maybe balls, and then you say that this one ball I'm not going to take. Okay, I have this one ball I'm not going to take. So in that case, when I want to find the total number of ways in which I can select, then it is n minus 1 PR. Okay, then it is n minus 1 PR. Now why this n minus 1? Because this one object, it is out of my space, you know. I just have to forget about that ball. So what will remain? Remaining will be n minus 1. Okay, I suppose I take that ball out. So what will happen? How many will remain? N minus 1 will remain. And with this n minus 1, I will use the formula n minus 1 PR. The second type of this is that number of permutations of R objects out of n distinct objects when a particular object is always included. See here what is happening? I'm excluding that object. That object is not there at all. So my options are limited to n minus 1. Here in the second theorem, they are saying, yes, I will always take that object. So what happens here is, this is R into n minus 1 P R minus 1. This R is very important, okay? Please remember, most of you tend to forget this. So R into n minus P R minus 1. Here, okay, I'm always taking that object. So why am I reducing it? That is because that is always taken. So every option that I have, every sequence that I have will always have that object. And so I have, it is already occupying that one place. So my R also becomes R minus 1. My R also, suppose like out of 5, suppose I have A, B, C, D, E. And out of there, I have to make pairs. Okay. From these 5, I have to select 2. Okay. From 5, I have to select 2. And I'm saying A is always there. Now what happens? A is always there. So all combination, only this one place I have to find a new. So what can happen? B, C, D or E. But A is always there. Or I can have dash A. Okay. I can have this or this. So that is why the formula becomes R into n minus 1 P R minus 1. Okay. And how many arrangements can be made out of the letters of the word drought? The vowels never been separated. So D, R, A, U, G, H, T. Okay. What are the vowels? Vowels are A, E, I, O, U. These are vowels. What are the others called? Consonants. All other alphabets. are called consonants. Okay. So how many vowels are there? There are 5 vowels. How many consonants are there? You can subtract. How many alphabets are there? -5. So those many consonants are there. Now drought. How many? What are the vowels here? A is a vowel. U is a vowel. The vowels never been separated. Okay. So that means they will always be together. So that means this word, actually how many letters are there? 1, 2, 3, 4, 5, 6, 7. 7 letters are there. But because these two are always together, this has now become 5-lettered word. Why? Because here and here also I can have AU or I can have UA. So that is 2 options are there. So how many arrangements can be made out of the letter? So out 7 becomes 5. So I have 5p5. So this is what? 5 factorial upon 5 minus 5 factorial. 5 minus 5 factorial is 0 factorial, which is equal to 1. So I have 5 factorial. But total number of ways that is arrangements, so that vowels are always together is how much? This 2 into 5 factorial, that is 2 into 120, which is equal to 240 ways. Okay. So I have tried to cover as much as possible in today's session. Whatever is remaining, let us see when we can find the time to do it. Okay. So I hope you had a great time learning as much as I had a great time teaching you. So meet you in the next lecture. Have a great day ahead and have a great Sunday tomorrow. Thank you all.